Hello and welcome again at Virtual Azure Community Day, live at Azure.Community. And if you're lucky you found us on YouTube, then welcome. So we have a whole day full of technical talks around modern day development using cloud technologies, namely Azure. And well, our next guest is an international guest, all the way from Belgium. It's Bart. Bart, welcome here in the studio in Utrecht. And yeah, thank you for being here. You've been MVP for a long while, I noticed.
I think about 7 years now, yes.
Yeah.
And thank you for having me.
Well, thank you for submitting the talk. We really liked it because what you're going to talk about today is about not developer productivity per se, but you want to keep security in the back of your mind.
Yes, exactly. I've been in IT for about 15 years, most of them being a consultant. So we see many projects at many different clients, and every single time, security is one of the things they struggle with. And often we as developers, we don't like doing security, so that's at the back of our mind. And my intention today is to bring that forward a bit and tickle people and tickle their mind to think about security. Then we're going to cover a lot of topics, not in depth because security is very broad, but I want to tickle the people, their mind, so they can think about it.
Yeah, isn't because what triggered me a little bit is like productivity and security in one sentence. I think that a lot of people are like, you know, there's a lot of talks about shifting left to security, but this is the first time I noticed somebody saying productivity and security in one sentence. So how would one think about that?
It's all about taking away the big steps. And the first impression of what somebody talks about security, it's too hard, it's too difficult, and we have to get to know the basics. And once you get to know the basics, it's part of your daily job, and you're going to start working with it, and you will keep being productive, and you won't think about security as a big step anymore.
So it's maybe the unknown that
Exactly.
scares people a little bit.
Exactly.
Fear is never a good thing.
No.
Thank you so much for joining us. Yeah, we're going to learn all about it. So we're heading well into the time. So please take it away. Thank you so much. And for you, if you are watching, please do send out a tweet or a toot or whatever social message using hashtag VACD. Share that you're watching, share the fun, and feel free to ask questions during the talk and in between. We are online and here to interact with you. With that, I want to say to Bart, take it away.
Thank you all for joining today. It's a very impressive stage. I remember my first virtual talks back in 2020 with COVID starting at my own home office. But when I came in here this morning, it was very impressive. So thank you for letting me come. Thank you all for joining. Who am I? My name is Bart Lannoeye. Like we already mentioned, I have been a Microsoft MVP for quite some years already because I like to share some knowledge. That's what we're going to do during the lunch here in the Netherlands as well. I like to call myself a technical architect because still from day to day, I'd like to write some code, be hands-on, know what I'm talking about. And you can find me on Twitter at Bart Lannoeye. What's not on the agenda today, that's the typical thing that we think about when we speak about security and as a developer, that's securing our application with authentication authorization. I hope you're all doing that already, so we're going to skip that. And what we're going to talk today is the challenges that you will see as a developer in an organization, mostly with enterprise software, but also with smaller applications, and the battle between developers on one side, and then IT and the CISO on the other side. So we're going to talk about taking shortcuts, the credentials, access control, networking. And certainly, if you look at the bottom ones, things that we as developers typically hate. But we'll try to take that away. Why do I need this talk? Well, first of all, we have to acknowledge that there is always a security risk. And often we as a human being are part or are even the actual risk. And that's what's often forgotten. Also, it's important to know that no company is small are large enough to not be at risk. It doesn't matter the size. If you have some data that's valuable, then you might be at risk. We can do our best to minimize that potential risk. And now, if you see these bullet points, you will say, well, Bart, you're being Captain Obvious. We all know that already. Do we? Let's see at a few cases from last year. The very first one, we're going to start with Microsoft, one of the biggest companies, software companies. They know about everything about security, and they try to help us with security. And even they were a victim of social engineering. It only took maybe a few seconds from a single employee to leak their credentials, and part of their code base was stolen by one of those groups. But it's not always social engineering. Often it's a technical problem. If we look at Crypto.com, they had a faulty two-factor authentication architecture, and about $30 million were stolen by hackers. By now, it's only worth half of it, 15 million, but it's still a lot of money, and you don't want that to be stolen. But sometimes it's not a big architecture thing. It can be very small as well. If you look at Flexbooker, that's a company that takes care of COVID vaccinations and their bookings in the United States. They apparently run on AWS, and they had a misconfiguration, and that resulted in a breach of several million users. And not even 2 months later, after they went through all their configuration with AWS, apparently there was even a second breach, again a misconfiguration, which resulted in another 19 million records leaked. So human errors are often the fault. And the final one, already mentioned on a previous slide, leaky secrets. In the end of 2021, Twitch and the known streaming platform had to come out because one of their secrets was leaked. And once you have the keys to the castle, you can do everything. 3 months later, Samsung and Nvidia and two more big companies had the same issue. In the case of Samsung, almost 7,000 secrets were found in the code base. That was open in the wild for some reason. And you would think if Twitch, Samsung, Nvidia, three big companies come out, people know that it's a risk, they will tackle it. Well, 7 months later, Toyota had the same problem, also a security breach, data breach, because of a secret that was posted on GitHub. No, if you have any secret in your GitHub repositories and it's in the public, it will only take a few minutes, and people will be using that secret maybe to mine crypto on your cloud subscription or steal your data. So the question might be, will you be next, or even when will you be next? Because we can be pretty sure that if we have something valuable, that we will be a target at some point. And hopefully we can do our best to protect against a breach. So often, if you look at enterprise companies, you will see there's someone called a CISO or someone taking up the security role. And the first thing that they might do if they see all those news messages, let's lock everything down. Because if we lock everything down, then there can't be any breach. Then, of course, you have other people in the meeting room. And first one might be from finance, and they will say, this will just cost too much if we have to lock everything down. Then IT will say, it's too much work to lock everything down and to secure it. And of course, we developers will say, if we lock everything down, then we can't do our job. Because we have no more the typical access, admin access that we had in our early on-premise days, where you have a single account and you can hop on all different servers and just do our job, debug something, deploy something, write a SQL query, do it in production, because that is the fastest way to fix something. But maybe not the most secure. If you look at these three topics, let's first tackle the first one, the cost. Because if we look at security, it's trying to find the balance between cost and risk. At the left side of the spectrum, we have the cost for trying to implement all security controls to make sure that the potential risk is very small, but then you have a real widespread of things that you have to do. For a small size company, and we once did that exercise, and we already came up to several millions to take actions to make sure that the risk was very minimal. You can't take it all away, but you can try to minimize it. On the other side, we say, I don't want to spend that large budget because we're a small company. Then there's of course the cost of a possible data breach. Either trying to fix it. If we look at, I come from Belgium. In December, the city of Antwerp had a problem. It took them more than a month to recover from that data breach, and they calculated that it costs them at least a tenfold trying to recover from it and trying to bring everything up again, compared to what they would have paid just to get out of the ransomware. So the cost of a security breach, not only the IT actions, but maybe also the legal actions could be very high. So we will try to find the optimum in the middle, to have a decent size of security at a reasonable cost. How do we approach it? Oh, there are many angles, of course, and it all depends. I have been a consultant for many years. It all depends what kind of business you're operating in. For instance, if you're a bank, typical banking applications that we know, they are very secure by design, because you don't want people to hack into a banking account and get rid of all your saving money. On the other side, maybe you have a simple cooking recipe application. It still has to be secure. You don't want anyone to change your recipes so somebody gets sick or even worse. But trying to recover from that, or the protection needed on that application, is a lot smaller. We have a public website, and it's all in the open, very reachable, compared to maybe a closed-off factory floor. From the outside, it's not that easy to get in, but even people visit your company floor, they could bring in a USB stick, so security still has to be top of mind. What data do you capture? Do you have any person identifiable data, names, addresses, maybe credit card information? If you start leaking that, of course, very sensitive and dangerous. Company secrets that you don't want to get out. But maybe on the other hand, like in a cooking recipe app, you have public available data. The data being breached is not that much of a risk. It's more protecting it for that they don't change it. What's your mitigation process? In the case of our recipe app, we could simply restore our database. If you look at a bank, you will want to prevent at all costs that someone gets to banking accounts and get money out. What's the monitoring process you have in place? Typically, through studies, we've seen that it takes almost a year between the actual breach and finding out that you're breached. So trying to bring that window down to a smaller period in case of a breach is very important as well. So we'll have to put some monitoring into place. And if you look at all these different approaches, what you will typically do if you start a security exercise, you will try to identify the threats and assign a likelihood, the impact, and the cost. And with the complete list, with all those measures, you can start ordering them and see where we will spend our money and what might be just too costly for a very small impact. You might skip that, and then it is, of course, to management to decide on that. They have to acknowledge that they still have a small risk, but the cost to fix it might be just too high. Very important as well, you have to coach each team in your organization, because security is often a human problem. So you have to coach them on the threats they can impact and be impacted by, so they can report them or help preventing any security. We've spoken shift left. It's often a thing that you can see with security, with DevOps. It counts here as well. Security is certainly not an afterthought. It should be part of every single phase in your software development lifecycle, and you should think about it as soon as possible. If during the analysis phase your product owner already makes the list of the potential threats, then the architect can design towards it, the developer can develop, and you have a tester testing all those threats as well. If you take security as one of the last things in your process, then it's not thought about, and then it might be very easy to find a few loopholes into it. So bring it forward in your development lifecycle and think about it as soon as day one. The use case that we're going to use to show a few of the things that we can tackle as a developer or an architect as a typical website. Like I said, a banking application already has security top of mind. They probably have a big security team there, but every single organization should think about security. So we're going to use a very simple website or API. Since we're talking about Azure, we're going to host it on Azure as well. What we're going to need for it today is a simple app service. And we're going to try to connect to a SQL database and a storage account. Nothing too fancy, but even with this very simple approach, you will see there are a lot of points where you can poke into the security of our application. What did I set up? Like I said, very easy, a simple API with a Swagger UI on top of it. The typical file new project. So we have a weather API to make it to expand it a bit. I also have the historical weather. The historical weather gets data from the storage account. The other one will go to SQL Server. If I switch to the code, two simple APIs, nothing too fancy. The first one, I get my connection string, and then I will use my connection string to open a SQL connection, execute a query, and then you will have a round trip to your SQL database. For the query execution, since I don't want to have the complexity of actual data and building a data model, I have a simple query, select one. It's not even hitting a SQL table, but select one is more than enough to do the actual round trip to SQL Server. So if at some point in your application you want to build health checks that you know that all your dependencies are up and running, for SQL, simply use select one. You don't have to know which tables are in there. It will do the full round trip to SQL Server and it will check, is the connection open, can I reach it? So that's an extra tip next to security. I simply return the data, the typical approach. And then my second endpoint, again, a connection string, but now for a storage account. I open a blob container client using the default SDKs, nothing fancy here. If necessary, I create my container. I get a CSV file and just stream back to the API. No fancy code, very simple, nothing can go wrong. We're going to cover several points, and the very first one is security keys. Like I've showed with the cases before, security keys, once they get into your source control, they're very easy to find. You have the key to the castle, you can do everything. So what does a developer say? I promise I won't commit my security key to source control. Well, that's something very easily said, but my alter ego wrote some code for this demo, committed everything since it was working, and what do we see in source control? Already my security key. It's very easy to be forgotten and to be checked in. And then you probably, and your team, you might say, there's a difference between environments. I want to have my connection string to easily connect to a dev environment to test things out. I want that to be very fluid so it can be productive. And maybe sometimes, if you have to debug something in production, you're going to change that key, but you won't commit it. I promise. There are solutions for that as well. Since we have our config file or app settings file already in source control, any change that you touch that file will normally be committed if you commit it and you don't pay attention to it. There's a command, git assume unchanged, that could help you out here. Works perfect until a new team member didn't run that command on his or her computer and commits the key after all. So what we're going to do, we're going to take the secrets out of our settings file, and we're going to let the CI/CD tooling fill it in during deployment. For the local development story, well, you have a problem. There are no more keys. You're going to have to solve that. The actual resources, if you want to use them, an Azure Service Bus currently not available as a simulator, so we have to connect to them. So we still need those connection keys. How are we going to do that? Still some questions to be answered. And once the secrets are deployed by your CI/CD tooling, be it Azure DevOps, GitHub, any of the ones available, they are still available to read after deployment by devs and by your IT team or anyone who has access to the resource. How so? Let me quickly show you. So I have my API already hosted on Azure, on an Azure website. You take the same domain name here, and you add SCM, just before azurewebsites.net. And what you'll see, you will log into a Kudu console. Very handy. It gives you a debug console. You have several tools. You can take a dump out, so to help you debug. Certainly a useful tool that you might be using in case of emergency. But the debug console not only gives you a debug console, it also gives you access to all the files. So if we go to the site, www.root, here we have an app settings.json file. Let's edit that, and here are my secrets. I can not only see them, I could even change them. So anyone with access to the resource, and a typical organization, that's about anyone in IT, and all the testers and everyone, they can see those resources. So if any of those users, their account gets hacked, you have a big problem. So what's the next step? You might already know the service. Azure has something called Azure Key Vault to store your secrets. So we should store all our secrets, but not only application secrets, also certificates, anything that you want to be stored securely, you can put in there. But then we still have the story, what about local development? And if we have a new resource, Azure Key Vault, doesn't my application, my app service, need a key to access the Key Vault? We still have the problem there. Well, for local development, there's something called Secrets Manager. A Secrets Manager will store your secrets in your user profile. It's not completely secret. Someone with access to the user profile can still read them, but it's already much better than put it into source control. If you look at the Azure part, once it's deployed, we have Azure Key Vault, and we're not going to use a key to connect to Key Vault. We're going to use managed identity. What are managed identities? Of course, the next question. It's a security principle in Azure Active Directory. Since we're using Azure, we're using all the benefits of it. And you have two types of managed identity. There's a system-assigned one, and that's part of the actual resource. So my app service will have an identity, and I will use that identity to connect to Key Vault. In case you're building a microservice architecture, good or bad one, and you want a single identity for all your serverless functions, app services, Kubernetes clusters, because you don't want to manage them all, you can create a user-assigned one, use that one, and assign it to Key Vault as well. So what we're going to do, we're going to give the Azure resource itself an identity and authenticate with that identity against Key Vault. So let's switch to Key Vault, service and Azure. As you can see here on the left, we have keys, secrets, certificates. With my secrets, I have my connection string for secure storage, the storage account, the same for SQL Server. Does it have to be a connection string with username and password? Of course not. You can go even a step further and use managed identity to connect to those services as well. But this is a first step. Now, we have a managed identity on my app service. And if we go to access policies, you can see here my application, which is the actual app service, only gets permissions to read secrets. And my own user can do about everything, but this single app service or any code running in that app service can only get the secret. This was the way how to do it until very short. Now you can also use role-based access control to use that as well. So if we go to the role assignments on the resource, you can see here on top again the app service, and now it has a role of Key Vault's secret user. So we have very granular access to only secrets in a Key Vault. So I mentioned role-based access control. What is role-based access control? Well, you give a user a certain role on a certain resource. The concept, very quickly, it's a security principle. So that can be a user, a group of users, an application, or a managed identity, user assigned or system assigned. Then, of course, we need the scope. On the bottom right can be your a whole management group. That's a combination of multiple subscription. You can go down to a subscription, a resource group, or the actual resource. It's a good practice to try to be as low as possible to give a very granular access. Then, of course, we need to define the role, and you have a role definition. If you have used Azure before, you most likely already know the top 3 ones: owner, contributor, reader. But every single resource has a very long list of more granular rights. You can create your custom roles as well, but with the built-in roles, you can already do a lot. If you're going to look up about the concept of role-based access control in the documentation, often they will say use the least privilege principle. Try to drill down to a single resource. If someone needs access on a single storage account, don't give them access to all storage accounts or all subscriptions. But Bart, there's a difference between environments. I want full access on my development environment, and maybe in most organizations where I typically come to, in the beginning, they also have full access on their production environments. Well, if we give everyone full access on everything, why do we even start with security? So we're going to have to lock things down. A possible structure or approach that you can take is shown on the screen here. In production, in my opinion, you should maybe see the resources, but you should not have access to actual data. So, for the storage account, SQL Server, you shouldn't even need access. You can approach them through your application because the application is tested secure, or maybe you have some tooling which is also tested secure to approach that. If you run SQL queries on a production SQL Server, one day you will mess up. We have all done it before. Just don't give anyone access, it won't happen. If you go down the chain, previous environments, staging, test environment, the same. You can see the resources. Normally, you shouldn't modify them. Maybe to help testing, you can give someone access to the actual data, but it depends if that really improves the testing cycle. For development, you could say, yeah, I want full access, but even there, my approach is just give them reader access as well. Maybe a contributor on a research group so they can do some things, but often I even go down to reader there as well. Data, again, the same. Why do I drill down everything or lock down everything? Okay. Devs and anyone in a team shouldn't have write access on production resources and not have read access through going outside of the boundaries of your application either. What often happens is that you have a production database and you're going to restore it to previous environments because we need a valid environment or as close as possible to production to test. Well, as soon as you start taking that data out, you will have again are opening up for security breaches, data breaches. So if there's any data in there that's personal identifiable, it should be never restored, or it should be cleansed first before you restore it to previous environment. That's an approach I typically take with organizations I visit. And then, of course, you have what if in case of support. If you need actual write access to a resource to change something to data, we're not going to give you full rights out of the door. We're only going to give it right in time. And for that, there's something called PIM, Privileged Identity Management. Again, part of Azure Active Directory. This time you will need a premium P2 license, so the most expensive license, because often security comes with a cost. The organizations that help you build software know that as well, that they can charge for security, but it helps you in the long run, and the cost of a breach often is a lot higher than the cost of preventing a breach. What does PIM do? It gives you elevated access to a resource just in time. You can enforce multi-factor authentication when somebody tries to get that access. If necessary, you can even put a justification approval process behind it. You can have access reviews, so you can see who can actually access the resource through PIM. And maybe the most important part, you have notifications when that person elevates access, and you have a full audit log. So if someone tries to get access to your resource, you get a notification, you know who does it, when it happens, so you can have a trail at all time. That's much better than giving anyone full-time access to that resource. So we're going to open up the door just in time, so somebody can do an action, maybe give them a window for 2 hours to do the things that are necessary, and after that, access or the role-based access control rights fall back to typical the reader. The third one topic we're going to cover is the pitfall of great tooling. We're happy to have great tooling. If you look at Visual Studio Code, but also other products like maybe Rider, there are plenty of them out there. They all help us to be productive, and that's what we like, to be developers. Someone who hasn't done it before, the screenshot that is shown there. I've built my API in code, right-click publish. I will create a new publish profile here, publish it to Azure App Service, Windows. You pick the one that you want to deploy to. Skip API management, but because who cares about security, right? We create a publish file. You simply hit this button here on top, and within a few minutes, all your code is live in production. That's being productive, right? Even today, at the companies that I come to, they use this every single time to go to production. It's opening up for problems. Yeah, Bart, you want to lock down production, I understand, but there's a difference between environments. I still want to do it for staging, for test, for dev. Yeah, maybe not. Friends, don't let friends right-click deploy. Only do it during demos. Use Azure tooling for speed during research, proof of concepts, but build and deploy should be done with automated pipelines. Most of you probably already know the concepts of CI/CD workflows. You have a piece of code, you will build it, you will run tests against it, and if those tests are successful, you have an artifact, you put that artifact aside, and that's versioned. Then the deploy part will take that artifact, deploy to an environment, maybe run some extra tests against it, and only change the configuration. I'm not going to say change keys, because keys are already stored in Key Vault, and we're only going to change the point where we deploy, and that point knows which Key Vault to use for all the secrets. We're not going to change those anymore. But Bart, there's a difference between environments. Why else would we set up all those environments? Well, because you keep nagging about environments, you can have them. But before I give you even an extra environment, security-wise, every single environment in your release pipeline should be considered as production. We don't want our secrets in source control, not for dev, and certainly not for production. We don't want to break production by hand because we give access. We're going to limit those role-based access control rights. And we're going to prevent breaking production by CI/CD, because the pipelines that we're going to set up, every single environment will have their own security principles to deploy only to that environment. And we won't reuse the security principles of a pipeline either, because we're all developers. We have one pipeline that works, we copy that for test, we copy that for staging, and maybe in one of the steps you forget to change the actual resource. It could be that your test environment is deploying to production or vice versa. By using different security principles, you take that away, you will have a failing build, but then you will see that there was an issue copying your pipeline. You will prevent lateral breaches by limiting role-based access control. So someone who has access to maybe development certainly can't try to mess with data in production. And we will prevent non-production data breaches. If we restore, that we will cleanse our data. A short resume of the things that we already seen. And then, and that's from reality, developers start saying, but then I can't work, I need to try out things, I need to do research. True. Development, you have tools like ChatGPT that can already do nice things, but we still have our value. We still have to research things, try things out. And for that, I give you yet another environment, because you like environments. You can get a sandbox environment from me. A sandbox environment is a place where you can do everything that you want to. Maybe you should put some cost management on top, that it doesn't cost too much. The great news is if you have a Visual Studio subscription, you already have your own Azure subscription. Simply go to my.visualstudio.com, find the Azure block there, activate it, and depending on the size of your subscription, you will have $75 or $150 every single month where you can try out everything. If that's not enough, then the company can set up a sandbox environment as well. And what you see on the picture here, we have our sandbox and subscriptions at the bottom right. There's a management group on top of there to group those. It might be a good idea to put some special policies, role-based access control in place, so you separate that from your production environment. Maybe prevent creating resources in Brazil, because those are very expensive. Sorry for everyone living in Brazil. And then maybe the final question is, if we try out things, we need maybe a new app registration. Do we put that in our main Active Directory, or do we set up a sandbox Active Directory as well, so the developers can play around? Depending on the size of the company, how you want to manage it, it's certainly a viable option. So we still get your tools, you still get your playground, but not where an actual code that one day goes to production is deployed. The next point, we have some principles in place now. We know that we shouldn't store credentials in our code base. We know that we should limit our role-based access control. So we have those things covered, but we still have some open windows in our architecture. You're probably going to ask, what are those security holes that are still left? When we were on premise, you had something in place by IT, that big firewalls. You have an enterprise LAN on the left, internet on the right, 2 firewalls in between, and a DMZ in the middle, where you host some websites that should be available from the public. If everything was set up correctly by IT, then internet couldn't go to the enterprise LAN, and that everything was secure. The cloud has the same. We should do or try to do the same. If you look at our solution, we left quite a few windows open. I put some red crosses on there, and you're going to ask, what are those issues that we left open? I already showed you the Kudu console for the application. If maybe before I'll show you the other problems, I'll run the application from Visual Studio, our little API. Because it wouldn't have been a developer talk without running it. Let me quickly try it out the API. That's Swagger is good for. And you see, I hit a breakpoint or an exception. Cannot open server, SQL dev security requested by the login, and the client IP address where I'm sitting now can't access my resource. That's a good thing, that you can't access your resource. SQL Server is one of the few resources where this is done by default. But of course, for demos, it's not as handy. So let's quickly solve that. Microsoft did a good job. Everything networking related you will find under networking. It's very easy. And by default, if you set up a SQL Server, public network access is disabled. Of course, if you want to load in some data from home and do some demos, you will enable that. And they even made it easy. At your client IP address, save. If I would now run my demo again, everything will go through. I will get my data out. Success. But you see a problem coming up here. I just added my client IP address, but tonight if I get at home, I will have to look at these timestamps that are luckily added to know which one is which. Apparently, this morning at the hotel, I added one as well. There's a don't delete, but I can't remember why. There's a home IP address, but with a whole team, I'm not sure which one. And there's an office IP address in there. So we see this list will grow a lot longer over time. Often, people don't clear up those IP addresses, and often we don't have a fixed IP address either. So we're poking all little holes in our network security. But at least SQL Server has it by default already on. If you look at Key Vault, similar networking, allow public access from all network. Same goes for storage account. So, as you can see on my side, networking-wise, every single resource has public access. Now you can say, Bart, SQL database doesn't have a cross, and that's secure. Well, that's mainly because it's a resource, sort of container on our SQL Server. The security is set on the SQL Server. First, networking-wise, similar storage accounts, if you put a container below that, and that would be very similar. So let's have a look. Let's have a look at cloud networking security. Azure Virtual Network is our primary component there. Then, of course, we have PaaS components, resources that are shared, the storage account, SQL Server. That's not something that we deploy ourselves. It's deployed by Microsoft. It's shared. So if we have our database, our own SQL Server on shared infrastructure, then we will need something to securely pull that into our network. That's where private link and private endpoint come into place. Once you set that up, Microsoft will themselves block access from the internet. So the resource is accessible from your own virtual network, no longer from the outside. That's for SQL Server, Key Vault, and all those PaaS components works the same way. And once everything is securely in a VNet, of course, you will have to expose it to the outside. And then we are looking at Azure Firewall, front door, application gateway, API manager. And there are multiple options there as well. API manager, the name says itself, it's for APIs. But again, look at what you need. Front door is typically global, application gateway typically regional. There's a nice overview on the Microsoft Docs site that tell you what to use for which use case scenario. HTTP, non-HTTP, plenty of choices. If you look at our very small solution, in a secure networking solution, you typically have your app service in the middle in your VNet. You see on the top and the bottom our shared PaaS components. We're going to access them through a private endpoint. So those are now secure from the external network. We put API management in front of it because we have an API. Our website itself, we're going to host on static web apps. Stacy showed us the power of that. So we're going to use that as well. And then we go finally expose it with an Azure front door. Put some Azure Active Directory in front of it for authentication authorization. Looks like a nice picture, and it does work. Also looks like a very expensive solution. If you have typically an app service running, access those resources, SQL Server, DTU based maybe, it's 100, 150 euros, already decent size, can bring it down to even half of it. If we add in API management, front door, all those resources, take the networking parts, you will easily up your price by a factor of 10, 20, even more. So that's very expensive. Again, Microsoft knows, but not only Microsoft, all cloud providers know that security is important. They need dedicated machines to set that up. You will pay for those dedicated machines. There's also a dev problem with security. We want to be productive. If I lock everything in a single network, you can't reach it anymore. And the case is that you want to go to the Kudu console, maybe download a log file, and you can't do it anymore because it's all in network. You can't deploy manually anymore, which is very good, but you can't deploy through CI/CD anymore either, because the hosted agents, be it on GitHub, Azure DevOps, Bitbucket, any of those platforms, those are in the public network as well. there might be an option to put a single hole in your firewall so they can come through, but then we have some holes again, so that's not the ideal solution. What the solution here is, you will have, or you will need a self-hosted virtual machine, build machine, a container. If you Google or Bing for solutions there are plenty of them to bring down the cost of that as well. But that machine has to be inside of your virtual network. And then the second part, and being productive, we can't verify our change anymore, the SQL data, other things, because it's inside a network. And one of the first things you might see someone trying to upload or download some files from blob storage, same problem. So you have to get into that network. Microsoft already has something in place, Azure Bastion, which is a jump host that you can access through the Azure portal. So you already have security of the Azure portal. Then go into Azure Bastion, you get inside your network. You can maybe set up a VPN, a client VPN, or from your office, a peer-to-peer VPN. There are express routes and just site-to-site VPNs for that. Or you can use Azure DevBox as well, which is in preview. And if you have been doing a consultancy and you get at a client where they give you a 6-year-old laptop to work on, then you will be happy to have an Azure DevBox. You can scale it up and have a decent development machine. But again, of course, the bigger you go, the more you will pay. So these resources does cost some money again. As mentioned before, security is trying to find the ideal balance between cost and mitigating your risk. So will you build that solution that I showed, the networking solution, for a simple app application? Probably not. It's simply just too expensive. But if you look at more enterprise applications, that's one of the things that we often do. And then the final one, the hazard of procrastination. We're all developers. We love procrastination. We love doing things at the last minute. You probably, or hopefully, are saying right now, Bart, we believe you, but we're working with Scrum. We have to deliver features first, and we will do security, right before we go live. We should know better. When was the last time you did underestimate the complexity of something you don't do every single day? And security is something we often don't do every single day. When was the last time you did finish a large project without bugs, important, on time, and had enough time spare to implement something extra as complex as security? And when was the last time you implemented a major change the week before a release and then you regret it? We've all been there. I've been a developer as well. I still write some code from day to day. We love to take our shortcuts, but it bites in our behind. Security is not an afterthought. We've covered it before. Pull it up front in your development lifecycle because it will help you to deliver secure software. Quick conclusion. I already gave one in the middle because those aspects are just too important to miss. Define your security needs of your project as soon as the analysis phase. If the product owner already says this is a potential risk, or you bring someone from the security team in, it's very useful. Fine-tune those needs according to the cost, or you won't build a complete secure network solution for a simple app recipe. Implement the security measures as soon as possible. So it helps you, and you can test them out from as soon as day one. You don't have to do it as an afterthought. Coach the teams how you work in a secure way, and get the help of experts, both internal in your organization or external as well. I'm not smart enough to do everything about security. Maybe some of you are, but it's always good to be challenged and to get the help of extra experts. What we haven't covered yet, and because of the sake of time, there are plenty of tools to help you here, monitoring both during implementation and after going live. If you look during implementation, SAST and DAST tools, static analysis tools, during CI/CD, Git hooks to prevent key commits, options there as well. Once we go live, if we look at Azure in particular, There are tools like Azure Defender, Azure Sentinel that help you out. Resources. Microsoft has done a great job on the documentation in the last several years. If someone asks me where can I find more, I typically point them to the Microsoft Docs, Microsoft Learn, because those resources are just so good. Cloud adoption framework for Azure. It's a proven approach for cloud adoption. Security is a big aspect of it. Once you go to the cloud with your organization, certainly have someone look at that as well to get you started. And then the third one, Azure Architecture Center, which has hundreds of architectures. And I quickly wanted to show that one as well to conclude. Simply browse the architectures. You can see right now there are 846 results. And if you put secure in here, there are 451 architectures that already give you a head start to get your help started. You can see here, DevOps for AKS, hybrid networking, plenty of those. Have a look at them. You don't have to reinvent the wheel. Use those to get started. And then certifications. Some companies need them for their partnership, but in my opinion, use the learn part of the certifications to learn the technologies. If you know the right technology to do the right job, you will already do a great first step in building secure software. As for developers, that's the developer associate, the AZ204. If you want to go an extra step further, there are plenty of security related topics as well. And with that, I would like to thank you. I hope that those 5 topics tickled your mind, that you're going to start thinking about security. I'm always available on Twitter. You can find some of those topics more into detail on my blog as well. And thank you for joining me.
Amazing. Thank you, Bart. That was really, really a good talk. And what struck me is that people can actually start working on security themselves and they do not need to do a lot of effort. It is not a very high lift to get started. That's what struck me the most in the beginning part of your talk. It's all like, actually, it sounds like working in a more secure manner actually saves me time, and I'm being more secure at the same time. Why don't people do this?
Because they might be afraid of security. It's such a broad topic, and it takes a bit of effort in the beginning, like using or taking the secrets out of your configuration. If you don't know that those tools are available and you can't do it, you won't do it. You need someone to tell you it's available. And once developers know that it's available, they will start using it, and it will feel like their second nature, and it will be easy. But it's again finding out what they have to do.
And look at the architecture doc.
Exactly.
Because those are amazing.
They are amazing. The docs in general, but also Architecture Center, they are amazing. They help you out to get started.
So if somebody's gonna think of, hey, I'm gonna deploy a new application, we're gonna need a new architecture, that would actually be probably the place where people should start to get secure from the get-go.
Exactly.
Awesome. Well, thank you so much for being here. I really appreciate it. I hope the people at home love this talk too. And it will, of course, be online, like all the talks for this day. We're going to go for a short break before our next speaker. Stay tuned. Thank you.